A room can feel hotter after sunset than it felt in the afternoon. The sun is gone, but the walls are still holding heat. The ceiling is still breathing warmth downward. The fan beside the bed is working hard, but the air does not feel cool. It only moves from one side of the room to the other, carrying the same trapped heat back across your skin. So you try what sounds logical. You hang a wet towel near the window. You place a bowl of water by the fan. You hope the room will cool down. For a few minutes, it feels like something is happening. Then the air turns heavier. The sheet sticks to your arm. The room does not feel cool. It feels damp, tired, and harder to breathe in. That is where the real mistake begins. A wet object does not automatically cool a room. Water only helps when air moves across it, picks up vapor, and carries that heat away. If the air has no clear path in and no clear path out, the room does not cool. It simply becomes a warm box with more moisture inside. The $7 setup in this video is not a fake miracle. It is not an air conditioner. It will not cool a sealed room like a machine. But when you place it correctly, it can help cool the air entering a room and make that incoming air feel cleaner and less stale. The key is location. Most people place the tray beside the bed, on a desk, or in the middle of the room. That is the weak version. The stronger version sits at the intake, where outside air first enters the space. That may be a window, a doorway, or a vent. The incoming breeze has to pass across the damp surface before it reaches the room. That is when the setup starts to make sense. It does not try to cool the whole room by sitting still. It cools the moving air before that air spreads through the space. And that is the difference between a cheap trick and a working system. Once you understand the path of the air, the $7 setup stops looking like a random hack and starts looking like a small cooling station placed exactly where the room needs it. Now let's build this in a way that actually has a chance to work. Start with the material you want: granular activated carbon, loose black granules, the kind sold for aquarium filters, air filters, or garden use. Do not use barbecue briquettes. Those are made to burn, not to clean or cool moving air. They can contain binders and additives, and they do not give you the same open surface. Also avoid fine carbon powder. Powder can make a mess, float into the air, and become something you do not want to breathe. Granules are the practical choice. Next, use a shallow tray. This matters more than people think. You are not trying to build a deep black pond. You are trying to expose as much damp surface as possible to moving air. A baking tray, a plastic storage tray, or any shallow container can work. Spread the activated carbon in a thin, wide layer. Air needs to pass across it, not get blocked by it. A wide, shallow layer gives the incoming breeze a better chance to feel cool before it reaches the room. Then wet it correctly. You want the carbon damp, not drowned. Pour clean water over it. Let it soak in, then drain off the extra water. If the bottom turns into a puddle, that water is not doing much useful work. It is just sitting there. Damp carbon gives the breeze a wet surface to pull moisture from. That is where the air starts to feel cool. Now comes the part that decides whether this works or becomes another useless internet trick. Place it at the intake. That means the window, doorway, or vent where air first enters the room. Do not hide it beside the bed and expect the room to feel cool. Do not place it in a dead corner and wait for magic. The incoming air has to cross the damp carbon before it spreads through the space. After that, create an exit, crack a door, open a higher window, leave a small gap on the opposite side. Warm air must have somewhere to leave. Without exhaust, the room keeps recycling its own heat, and the cool effect fades fast. Then check your climate honestly. In dry air, this setup can feel cool enough to notice. In humid air, treat it as an air edge cooler, not a room AC. It may help the incoming air feel cool and easier to breathe, but it will not turn the whole room cold. And keep it safe. Use it only where air is moving. Do not seal it in a closed room. Do not breathe carbon dust. Do not leave dirty standing water for insects. Rinse the tray, re-wet the carbon, keep the air moving, and let the system do the small job it was built to do. Help incoming air feel cool, cleaner, and less stale. The first thing to understand is this: a room does not cool down just because you put something wet inside it. That is the part people miss. They think the wet towel is the solution. They think the bowl of water is the solution. They think the fan is the solution, but none of those things can cool a room properly if the air has nowhere to go. A hot room is not just hot because the air is warm. It is hot because the heat is trapped. The walls have absorbed heat all day, the ceiling holds it, the floor releases it slowly, the furniture stores it like a sponge. Then, when you turn on a fan, the fan does not remove that heat. It only pushes it around. That moving air may feel slightly better on your skin, but the room itself is still loaded with heat. That is why the $7 setup has to be treated like an airflow tool, not a magic object. To make air feel cool, you need movement, but not random movement. You need a path. Air must enter from one side, pass across the damp surface, pick up a small amount of moisture, drop a little heat through evaporation, and then continue through the room instead of sitting there. If that path is broken, the setup becomes weak. If that path is right, the incoming air can feel cooler before it spreads across the space. This is why placing the tray in the middle of the room is usually a waste. It may look like you are doing something, but the air around it is barely moving. The water sits there, the room becomes more humid, the fan keeps spinning. You wait for the room to cool, but the air only feels heavier. The stronger setup begins at the window, the doorway, or the vent where outside air first comes in. That is the intake. That is where the room gives you a chance to change the air before it reaches your body. Place the damp charcoal tray there, and the breeze has to cross it first. Now, the setup is not trying to cool dead air. It is working on moving air. That small difference changes everything. You stop fighting the whole room at once. You work with the flow the room already has. You cool the incoming air a little, clean the edge of the smell a little, and guide that air through the space instead of trapping it beside the bed. This is also why a second opening matters, a cracked door, a higher window, a small gap on the opposite side. The warm air needs somewhere to leave. Without that exit, the cool effect fades quickly because the room keeps swallowing its own heat. The goal is simple: bring air in, pass it across the damp surface, let it move through, let warm air leave. That is the difference between hoping a trick will work and building a small system that actually has a chance. The real mechanism is simple, but it is easy to misunderstand. Water does not cool air because it is wet. Water cools air when it changes form. When liquid water turns into vapor, it needs energy to make that change. That energy comes from the air moving across it. So as the air passes over a damp surface, some of the water evaporates, and a little heat leaves with it. That is why a breeze over sweat feels cool on your skin. That is why a damp cloth near moving air can feel cool. And that is why this setup only works when air is actually moving. Still water sitting in a tray does very little. Damp material in the path of a breeze does much more. The breeze gives the water a way to leave. The water takes heat with it. The air that comes through can feel cooler, softer, and less harsh than the air that came in. But this is where people get disappointed if they expect too much. Evaporation has a limit. Dry air can take in more water vapor, so dry air lets this system cool better. In a dry climate, the air is almost thirsty. It pulls moisture off the damp surface faster, and the cooling effect becomes easier to feel. Humid air is different. When the air is already carrying a lot of moisture, it cannot accept much more. The water evaporates more slowly. The air may still feel a little cooler at the intake, but the drop will not feel dramatic. In a humid room, the goal is not to turn the whole space cold. The goal is to take the sharp edge off the incoming air without trapping more moisture inside. That is why airflow matters so much. Now, the activated carbon adds a second job, but it must be understood honestly. This is not barbecue charcoal. Grill briquettes are made for burning, not for filtering room air. Activated carbon is different. It is processed to create a huge network of tiny pores. Those pores create a lot of surface area inside a small amount of material. When air passes across enough activated carbon, some odor compounds and certain gases can stick to those surfaces. That process is called adsorption. You do not need the technical word to use it, you only need the practical idea. Moving air touches the carbon, and the carbon can help reduce some of the stale smell riding in that air. But it needs contact, it needs airflow, it needs enough material. A tiny handful hidden in a corner will not cool the room or clean the air in any meaningful way. A damp layer placed at the intake has a real chance, because the incoming air is forced to meet the surface before it enters the room. That is the real system. Water helps cool the moving air, activated carbon helps handle part of the odor load, and the room only benefits when the air has a clear path through it. This is where the setup stops being a little trick and starts becoming a system. A hot room is rarely fixed by one object sitting in one place. The room is not just holding warm air, it is moving heat, moisture, and stale air in slow patterns you usually do not see. If you want the room to feel cool, You have to guide those patterns instead of fighting them. Start with the intake. The best intake is shaded. If the sun is hitting the window directly, the air around that window is already warmer before it enters the room. A shaded window, a porch side opening, or a vent on the cool side of the house gives the setup a better starting point. You are not asking the tray to perform a miracle, you are giving it air that still has a chance to feel cool. Then place the damp carbon tray right in that intake path. This is the working surface. The breeze touches the damp material, water evaporates, and the incoming air can feel cool before it spreads into the room. The activated carbon is there to help soften some stale odor riding with that air, but it needs contact. That is why location beats decoration. A tray placed where air moves can do useful work. A tray placed where air sits becomes almost pointless. If you have a small fan, use it gently. Do not blast air so hard that it sprays dust, dries the tray too fast, or makes the room feel chaotic. A slow pull across the damp carbon is enough. The goal is steady airflow, not noise. You want the room to feel cool and breathable, not loud and restless. Now give the warm air a way out. Open a door crack, a higher window, or a small gap on the opposite side. This exhaust path matters. Without it, the room keeps swallowing its own heat. With it, the incoming air has a path to move through, and the old warm air has a reason to leave. Each morning, reset the system, re-wet the carbon until it is damp, not flooded, pour off extra water, check for dust, check for dirty standing water. If the air is humid, be honest, the setup may still help the air feel cool at the edge of the airflow, but it will not act like a real air conditioner. That is the upgraded way to think about it. You are not trying to make the whole room instantly cool with a tray. You are making the air path feel cool where it enters, moves, and leaves. That is why the $7 version can feel surprisingly useful when it is placed correctly, and almost useless when it is treated like a random hack. This is the part I want you to remember before you build anything. A hot room is not beaten by one object, it is controlled by a path. When air enters from the shaded side, crosses a damp surface, moves through the room, and leaves through another opening, the whole space starts to behave differently. It may not become cold, it may not feel like air conditioning, but the air can feel cool enough to take the edge off the heat, and sometimes that small difference is what makes the room livable. That is the honest promise of this $7 setup. It is not a machine, it is not a miracle, it is not a replacement for real cooling when the weather is dangerous. If the room is extremely hot, if someone is elderly, sick, pregnant, very young, or already showing signs of heat stress, do not rely on a homemade setup alone. Get them to a safer, cooler place, use real cooling when health is at risk, but for a stuffy room, a small workspace, a camper, a shaded window, or a bedroom that only needs the incoming air to feel less harsh, this method can help. It teaches you something most people forget. Comfort is not only about temperature. It is about movement, moisture, shade, and escape. Warm air needs a way out, fresh air needs a way in. Water needs moving air before it can help anything feel cool. That is why the tray matters less than the system around it. A damp carbon tray in a dead corner is just a wet object. A damp carbon tray at the intake, with an exhaust path on the other side, becomes part of the room's breathing pattern. The air enters, touches the damp surface, feels a little more cool, carries less of that stale edge, and keeps moving. That is when the setup earns its place. So build it simply. Use granular activated carbon, not barbecue briquettes. Use a shallow tray, not a deep puddle. Keep it damp, not flooded. Put it where the air enters. Give warm air a way to leave. Check the humidity. Keep it clean. Keep the air moving. If your room still feels heavy, that does not mean the idea failed. It usually means the path is wrong, the air is too humid, the intake is too hot, or the warm air has no exit. Fix the path before you blame the tray. Tell me in the comments where you would place this first. A bedroom window, a garage workspace, a camper, or a back room that never seems to cool. And tell me if your climate is dry or humid, because that changes everything. If this helped you see cooling differently, subscribe for the next setup. We will keep focusing on simple, low-cost systems that make a home easier to live in without pretending a $7 idea can do the job of a full air conditioner. The goal is not to chase tricks. The goal is to understand the room well enough to make the air work for you.